Hello students, welcome back, and now let us talk about RL circuits. That means there is one inductor and one resistor and there is no source, so it is still a source free circuit. Now if I apply KVL by assuming that I is the common current flowing, then we can say VL plus VR equal to 0, and then we write VL is LdI by dt and we derive it. We will get I of t as I naught e raised to power minus RT by L. And now in this equation, if I assume tau is equal to L by R, we will end up with a very similar equation, which is I of t is I naught e raised to power minus t by tau. If you see the previous equation which we had for RC circuits, that was V of t equal to V naught e raised to power minus t by tau. This is our characteristic equation for any first order circuit. Always we will get like this whenever there is no source. The only difference for capacitor, the tau was R into C. For inductor, it is L by R. So once I got this equation, then we can get any other parameter also. Now let us take one example. So I have this circuit here, and we are asking that if I naught is 10, find I of t and Ix of t. This is I which is in the inductor and Ix in the resistor. So this is the network which is given to us. So what we can do, we can apply KVL between these two. I can assume this is I1, this is I2 as it is shown here. And then we write the equation in loop number 1. In loop number 1, L di by dt will be the voltage across this. L is 1 by 2 and current is I1. So L di1 by dt. And what is the drop in 2 ohm? 2 into I1 minus I2. So I got this equation. Then in the second, we have this current. This is the voltage source. This is one resistance. This is another resistance. And we can write that equation also. So once we solve them, we can get, भाई ये तो कुछ और ही निकला, इसको तो रहने दो, 3, 2, 1. So now let us solve this circuit. I have this 10 volt source, 2 ohm. This switch is open, and then these are the things. At t equal to 0, we'll close the switch. So one thing that we realize, if I close the switch, then the 10 volt, whatever current it is producing here, whole current will go in this branch, and this loop will have the effect of 10 volt. Nothing will go beyond this. That means the circuit which is on this side, that is a source free circuit after t equal to 0. So these are the things we must identify very clearly when the circuit is given. Now when we are talking for t less than 0, this switch is open. The inductor will behave like short circuit. That means 6 ohm will be out of computation, and I will have this simple series network. And in this network, the current which is flowing in 2 ohm is same as 3 ohm is same as current in the inductor, and that will be 10 by 5, which is 2 ampere. So we got it. Now what is the voltage in the 3 ohm resistor? That will be 2 into 3, and I got 6 volt. So these were the easy things. We are done with this. Now we talk about t greater than 0. When t is greater than 0, 10 volt, 2 ohm will not be part of our RL circuit. They are gone, and we are left with this remaining circuit, which is this one. Now if we see this 3 ohm and 6 ohm, they are parallel to each other. We can make a combined resistance of 2 ohm. And tau, which is L by R, and I got L is equal to 2, R equivalent is 2, so I got tau is equal to 1. So that means what is my characteristic equation? I of t is equal to I naught e raised to power minus t by tau. I naught is 2 and t by tau is 1. So I got this. Now this is the equation of current in the inductor. This is not the equation for current in this resistor or this resistor. Now these two are parallel to this inductor. So what will be V naught? V naught, if you see, I can place this 3 ohm here like this. That means 3 ohm is parallel to 6 ohm and parallel to 2 Henry. But there is one catch. The voltage across inductor we are measuring plus above, minus below, because current is entering from plus. But my observation voltage across this 3 ohm is plus below, minus above. That is V naught. So I can say that whatever is the voltage across inductor, minus of that will be the voltage across 3 ohm. So what is the formula for voltage across inductor? V is equal to L di by dt. So if my voltage across 3 ohm is minus of VL, that means minus of L di by dt. I just do it and I got the formula for voltage across 3 ohm resistor also. And if I now want to calculate what is the current in this 6 ohm resistor, then this current is nothing but this voltage divided by 6 ohm, and this voltage across 6 ohm is same as VL. So I will simply say VL by 6. So I got this answer also. So friends, first order RL circuit without any source, they will focus only on two things: finding I naught and tau. Then you get your characteristic equation. That means I of t is equal to I naught e raised to power minus t by tau. Once I have these equation, then start finding the other parameters. So keep learning. Thank you.